Hi, everybody. Welcome to the 10,000 hour community. And look who's joining us today. This cute face over here. This is Brucey. He's my boy. He loves a good scratch. Yes, and he loves being on the couch too. Probably your favorite time of the day. So today we are doing lists and strings. That is going to be a revision on Unit 4 of the Saylor Academy Introduction to Python. We are getting free certification, the course materials all free. That is our motto on this channel. All the resources, all the tools that you need to learn for Web3 are free. So if you're new to the channel, just some general housekeeping. We have 5 playlists. So the idea, those are there, right, to help ease your learning. So our first playlist is step 1, which is the Python basics. So that is where this specific video will fall under, because this is actually a revision for our basics on Python to get our full certificate. At the end of this playlist, I haven't got there yet, but I will actually have an audio book on basically a study guide of the basics in Python, which you can listen to as part of revision. So I'm excited to do that. Our second playlist is where we've already started our intermediate Python. Our third playlist is where we actually apply what we've already started learning in programming to Web3. I've got a fourth playlist. As an LLB graduate, I am particularly interested in the law and how it applies to Web3 and that legal framework. And I also have a playlist which is music. So that will actually connect you to my other YouTube channel where I focus on creating content to help you focus with your studying or your work. I try to make it conducive to that. So if you like to have background music while you're working, studying, or even just relaxing, you can consider giving my channel some support. So let's dive in. You can see here we've already covered 30% of the introduction to Python. Tell me how you guys found the exercise for Unit 3. I must be honest, I struggled a little bit. So I might just be doing some additional content on flow control statements. Those are our if statements, our for loops, our while loops. Yeah, it was a little bit tricky. But I have also noticed on the Saylor, like the website with the questions, some of them are theoretical. And I'm not sure how those get marked because, you know, everyone's answer won't be exactly the same. But anyway, those don't count towards marks. It's just to help us make sure we understand and also practice. So let's go on to Unit 4. So this says it will take us approximately 6 hours. We've been going through them quicker because we've actually covered these in our early videos, and this is really just revision. But depending on how today goes, it might have to be split into 2 videos. So lists and strings. Upon successful completion of this unit, we will be able to explain lists and indexing, write simple programs that apply list and string methods, explain and apply slicing, and write programs that plot and visualize list data. We should be quite comfortable with the first three from what we covered so far, but let's see. Python lists. A list is a data structure capable of storing different types of data. Run this set of commands in Replit. So with regard to Replit, you need to use Python PyBar, okay? So the Academy is a bit out of date and we've found that we couldn't type in the console. So especially in the beginning units where you're just working in this right-hand side here, you're not going to be able to write. At this point though, we're working here in the main section. But you're going to need Python with PyBar to write in the console. So we know lists have these square brackets, and we know that we can put numbers in them, we can put integers, floats. It looks like we can put in Boolean values, strings. You should see the list output to the screen as well as the data type of the variable. So this is the name of our list, a list example or example. I think we know how this will look, but anyway, I'm going to run it in Replit. So it's printed our list, right? It has indicated that it is a list type, and the list contains 10 elements. Remember, all the elements are separated by commas, okay? And we use len to work out how many elements are in a list. Should I zoom in so you guys can see better? I think so. You should see the list output to the screen as well as the data type of the variable. Notice that the list contains bool, int, string, and float data. It also contains the results of relational and arithmetic operations. Any valid data type in Python can be placed within a list. So we had a plus b, so it worked out 2 plus 3, which is 5. And that's the value it gave us over there. The data contained within the list are called elements. The list you printed contains 10 elements. You can figure this out by counting them by hand. There is also a command called len that will give you this information, which you can see in the example. Len is a very useful command. We're going to see how useful it is, especially when it comes to indexing. Pay very close attention to the syntax used to build the list. The left square brackets and right square brackets is known as a container. Elements must be separated by a comma when building the list. Pay very close attention to this example. Add this code on the line after. You can do that. We're going to create that list, and then we can say print. And then let's run it. So it gave us an error. A list example is not defined. We can just print a list again, just copy and paste it. So the list contains 10 elements. So we created a new variable name for a list exam, right? Which is TMP. Let's see here. Okay. You should see the list output to the screen as well as the data type of the variable a list exam. Oh, we've done that, sorry. Notice that changing the value in the variable TMP also changed the value in the variable A-list exam. Initially, this appears to go against what we learned about the assignment operation. For reasons that will be discussed in a later unit, when it comes to lists, Python views both variables as occupying the same space in memory. There are different names that refer to the same data. How then can we truly assign the list to a new variable that occupies a different place in memory and can be modified independently of the variable A-list exam? So notice here it still said that it had 10 elements. TMP3 VB, yeah, so it inserted VBNM. It basically replaced 96, which was the third element. Or no, ASD, no. How do we still end up with 10? So we have 1, 3, 4, ASDF, VBNM, true, 9.6, oh, 0, 1, 2, 3. So it replaced 96. When we did this over here, TMP square brackets 3, we replaced 96 with VBNM. So we didn't add it, we just replaced it. So this is interesting. So what we would do is we would say TMP equals a list exam dot copy. So it looks like we would use dot copy to basically copy this list over here, a list example to TMP to basically create a new list. Then we print TMP, we print a list, we change the third index on TMP to VBNM, and then we print both lists again. So let's see what happens. I anticipate that basically what will happen is it will print this list as TMP, where 96 is replaced with VBN, and it will print the original A list. So I was correct, it's just the other way around. It's temp first, TMP, and then A list. So by using .copy, we create a copy of the list. This example introduces some new syntax that will soon become second nature. The command alistexam.copy is your first introduction to object-oriented syntax. The copy portion of this command is what is known as a method. It is connected to the variable alistexam using the period or dot notation. So it's dot copy. This command makes a true hard copy of the variable A-list exam so that modifications of TMP do not affect the A-list exam. Every variable type in Python is what is known as an object. You will learn an immense amount about objects as we delve deeper into the course. The main point to realize is that there are several methods available for use with lists. The copy method we just introduced is one of them. Some other important ones worth mentioning at this point are pop, append, remove, and insert. Pay attention to the sections that describe these methods in detail. Continuing with our previous example, run this set of commands in Replit. So this will basically, remember there's 10 elements, but when we index, there's only going to be 9 because we start counting at 0. So I'm going to delete this and just run that. So to print the index within a list, you need to use square brackets. And then you see it's gone one by one, and it's basically printed the values of the respective index numbers. The elements contained within a list can be referenced using what is known as an index. Notice that Python begins indices by starting at a value of 0. So if a list has 10 elements, the first element on the list is referred to using an index of 0, and the last element is referred to with a value of 9. This can take some getting used to if you are used to counting starting with the number 1. A common error when first starting with lists is attempting a command such as print a list example 10 on a list with 10 elements. Such a command would yield an error message and halt program execution because there is no such element. The index is the key referring to an element within a list. You must see the programming equivalence between an element and referencing the elements via its index. Continuing with our example, we now say C equals 3 plus a list exam, and we're referring to the index 1. So 1, the index 1 would actually be the second elements on the list. Yeah. So a list, and then we say a list exam 1 equals C plus a list exam 0. So this would be the first element. Print C and then print a list exam. So our second element is 3.4. So 3.4 plus 3 is 6.4. That's what C is when we say print C. As for this one, well, a list example 1, again, that would be 3.4 equals C, which is now 6.4 plus element 1, which is 7.4. And we remember by doing this, we're replacing. So we said, C is 6.4 plus 1. So we essentially replace index 1, which is element number 2, 0, 1, you have this one here, 2, and we replace 3.4 with 7.4. The whole point of using a list is that a programmer plans to reference elements further down in a program. In this case, 3 is being added to the elements index with 1, elements with index 1, and then that element is being assigned a new value by referencing the key element with index 0. Mastering the gymnastics of using indices is key to becoming an advanced programmer. In this example, we explicitly typed out all of the indices of every element. What if we had a list with 1,000 elements? This is important. And we wanted to output them all one by one. Would we have to type 1,000 commands? If we did, we would be completely disregarding the power of loops, which we mastered in the previous units. So consider this code as an alternative. For I in range, we did cover range in Unit 3. And then the range is basically calculated as len, a list exam. So this would be the number of elements, okay, in a list exam. Then it will print elements I, and it's going to go through, it's a loop, so it's going to go through each element equals, and then a list exam I. Notice how the result of the len command is being used to define the range of the loop. Lists, indexing, and loops are related topics. It is important to understand how they are related to become a seasoned programmer. One more important point must be mentioned about list indexing. Recall that any valid data type in Python can be inserted into a list. Lists are a valid data type, therefore it is possible to have a list that contains lists, as this example shows. So we have a list called X, a list called Y, and a list called Z. And within Z, we've actually put in X and Y, which are lists in and of themselves. So let's run this code. So we first printed, don't know why it's empty. X, right? We first printed X, which you can see is a list within the list. We printed Y, which is these two elements of this list. And then obviously for Z, we've also got that additional floating number there. Notice how, according to the len function, this has 3 elements. So it might look like more because there's all of these happening in here. But actually, this list is considered 1 element. And the second list is considered a second element. So that's why there's only 3. After running this code, you should see that the list Z contains 3 elements. The lists X and Y are said to be nested within the list Z. Therefore, indexing elements within these lists will require a second index as follows. So in this case, if we say 0, we're referring to index 0, which is basically 1 over here, which is X. And within X, we want to print the second index. The second would be 0, 1, 2. It would be 5. So I have a feeling it's going to print 5. Prints 5.5. Yeah, sorry, it is 5.5. I didn't notice the decimal. If we look at 1, 0, so basically our first index on Z, right, is 0, 1. That would be Y. And we're looking for basically the first element, which is negative 300. So let's check if we write. And that is correct. Where the second index refers to elements within the nested list, To print out all elements on a nested list, we could also use a loop. For j in range, len x, print z 0j. So that's how you would print the elements of a list within a list. One very useful feature of Python is its ability to reference elements in loops without the need to reference an index, as this example shows. For value in Z, print value. In this example, the variable value iterates across all the values in the list Z without the need to create an actual index. This is a very powerful feature in the Python programming language. Practice as many examples as you can. It is important to master indexing before we move forward to slicing. Let's try and print that and see what happens. Okay, so remember it has 3 elements, so it's printed all 3, specifically the details. So we would use value. There are more notes, so we can go ahead and look at that. Done that. So I'm going to read from here, list basics. A container is a construct used to group related values together and contains references to other objects instead of data. A list is a container created by surrounding a sequence of variables or literals with brackets, the square bracket. For example, mylist creates a new list variable mylist that contains the 3 items, 10, ABC, and 2.5. A list item is called an element. A list is also a sequence, just like string, meaning the contained elements are ordered by position in the list, known as the element's index starting with 0. For example, 3 in my list is at position 2, 0, 1, 2. Or over here, we've created an empty list. We can add another element to the list using dot append. So we've learned about dot copy to basically copy a list to a new variable name. We also have dot append. So we can add Sam. You can see how it's added Sam at the end of the list. In this example, we have my list. We then take an index 2, which is 0, 0, 1, 2, which is basically the value 3. And we're now changing it to 7. So now it will print 1, 2, 7, 5. Len of my list will get the length of the list. Remember, len refers to the elements. So while there may be 4 elements, there will only be 3 indexes or indices because we start counting from 0. Okay. We use dot pop to remove the last element. Or if we want to be specific, because notice in this example, dot pop is empty, If you want to be specific, you can remove the index 1. So in this case, it would be, having removed 5, it would be 0, it would be 2, right? So that's right. So we've removed 5, we've removed 2, so we're left with 1, 7. We also have dot remove, which finds and removes first occurrence of value 6 in the list. So it becomes 10, 9, 8, 7, 5. I wonder why dot remove doesn't work based on the index. And then we also have dot index, which is to get the position or index of value 8. So we should know it would be 2. So that will tell us what the index of the value 8 is, which in this case is 2. 0, 1, 2. My list dot insert 3, 12. Insert 3, 12. They don't explain that one much. I understand. So if we're looking at insert, we're saying at index 3, we're going to insert 12. So we have replaced 0, 1, 2, 3. We've replaced 7 with 12. Nope, we haven't. It looks like we've inserted it. Oh, so we're not replacing. We're inserting. That makes sense. So between 8 and 7, previously there was nothing. We're now inserting 12. 12 will effectively become the new index 3. 0, 1, 2, 3. Assume we have two lists. A, which is a list of numbers 1, 2, 3, 4, and B, which equals the strings A, B, and C. How to display the last element of the list A? Well, I would start by doing a len. Should we try this? Let's just delete this. And we'll paste this in. So we want to work out, according to the question, the last element of list A. So we would say print len A. So that's going to tell us how many elements. I'm still used to Java. So we know it's 4 elements, so the last element would be 3. The last index, sorry. So print A square brackets 3 is how we would print 4. Okay. How to remove the last element from the list B? I think we would just say, what would we say? I know we would use remove. So we use dot remove. Let's go back up. So we've got dot append, which is going to add to the end of the list unless you probably specify. We have dot pop. If it's empty, it will remove the last element, but otherwise you can actually specify the index. And then we have dot remove, but it seems like remove is like it uses some sort of, or it does some sort of equality checking. So in this case, it's not thinking of the index 6, it's looking for the number 6. And then we have dot insert, where we can specify in brackets at what index we're going to insert a new number. So append, I just want to just double check it moved it to the end of the list. Yeah. So going back to our question, the question was how to remove the last element. Well, we know that we could use pop. We could say dot pop. So we would say a dot pop. We'd say a dot pop, and we just leave it empty. And now we print a. We have removed 4. So it's 1, 2, 3. The function called len a returns the length of list A. Write the command to display the sum of the lengths of lists A and B using len, print, and plus. So we could call it sum A, sum lists. Probably a terrible name. So we would say len A plus len B, and then if we print sum lists, anybody home? Worklets is out of sync. Yeah, okay. Relax. So it's given us 6 because we have 3 elements there and 3 elements there, because remember we removed 4. So 6 is correct. Still working with the list. So now we're going to add back 4. So let me delete this. What will happen if you type the following statement? That's a good question. Print A plus B. No idea. Creates one list. No. I don't know. How can we save the result of A plus B so that we could use it sometime later in the program? So we would use copy. So we would say was copy, wasn't it? It was dot copy. So if we said C equals, well, can't we just say C equals A plus B? And C. It worked. Hey, you just assign it a value. We're going to mark that as completed. Next. As it's been 41 minutes, I'm going to quickly take a short minute break and we will then resume. And it looks like we're going to go into more detail on indexing for our revision today. I'll see you shortly.
Any of that show.
That's fine, bro. You're the person that we make fun of. We take you and we take your chart and we make fun of it. We put the two charts next to each other and we cuckold you and we say, look, we're banging the mad gains.
Currency. Collectively, central banks are working to issue in a new system, and that means destroying the purchasing power of the currency and bringing down an entire class of people with it.
Characterize Bitcoin as a digital currency. You can call it digital gold. You can call it digital cash. You can think of it as digital money. You can think of it as digital property. You can think of it as digital capital. You can think of it as digital energy. You can think of it as a digital asset.
Government could just stop Bitcoin tomorrow. Liberty Reserve was shut down across 42 countries. Bitcoin can be like that, tomorrow banned. The way that they shut Liberty Reserve down was the Americans issued a financial services order. Anyone who took Liberty Reserve was banned from the banking system anywhere on earth. Basically, it means your whole company's wiped off the face of the earth. And they could do that, and they can do that to Bitcoin right now.
This is fine.
we are back. Let's read some more on lists. So like a string, a list is a sequence of values. In a string, the values are characters. In a list, they can be any type. The values in a list are called elements or sometimes items. There are several ways to create a new list. The simplest is to enclose the elements in square brackets. So we know we can quite easily identify a list like that. The first example is a list of 4 integers. The second is a list of 3 strings. The elements of a list don't have to be the same type. The following list contains a string, a float, an integer, and another list. A list within another list is nested. A list that contains no elements is called an empty list. You can create one with empty brackets. As you might expect, you can assign list values to variables. So we have your cheeses, we have numbers, we have an empty list, and then we can print all 3 lists. Cool. Lists are mutable. The syntax for accessing the elements of a list is the same as for accessing the characters of a string, the bracket operator. The expression inside the bracket specifies the index. Remember that indices start at 0. So on our cheeses list, this will print our first element, which is cheddar. Unlike strings, lists are mutable. Mutable meaning they can be changed. So when the bracket operator appears on the left side of an assignment, when my assignment is equal, it identifies the elements of the list that will be assigned or basically changed. So in this case, index 1, which is, if we count from 0, this is 0, this is 1. So 1, 2, 3 will change to 5, and effectively the numbers list will become 42, 5. The 1th element of numbers, which used to be 1, 2, 3, is now 5. Figure 10.1 shows the state diagram for cheeses, numbers, and empty. So cheeses, 0 is cheddar. These are our indices. 1 is Edam, and 2 is Gouda. On our numbers list, 0 is 42. 1, remember we changed it to 5. And our empty list, well, there's nothing. Lists are represented by boxes with the word list outside and the elements of the list inside. Cheeses refers to a list with 3 elements, index 0, 1, and 2. Numbers contains 2 elements, which was 42 and 5. The diagram shows that the value of the second element is being reassigned from 1, 2, 3 to 5. Empty refers to a list with no elements. List indices work the same way as string indices. Any integer expression can be used as an index. So remember, integer is a whole number, okay? So not a decimal number. If you try to read or write an element that does not exist, you get an index error. If an index has a negative value, it counts backward from the end of the list. The in operator also works on lists. So Edam in cheeses is true because there is Edam. Or brie in cheeses will be false because there is no brie. Traversing a list. The most common way to traverse the elements of a list is with a for loop. The syntax is the same as for strings. So remember, we covered this for Unit 3, the differences, not really the differences, but when you want to use a for loop and when you want to use a while loop. So normally a while loop will run for as long as a condition is true. However, with a for loop, you want to run over, it's like certain elements in a list, or you know how many times you need to run the loop. So for cheese in cheeses, print cheese, and then it will basically print the cheeses. This works well if you only need to read the elements of the list. But if you want to write or update the elements, you need the indices. A common way to do this is to combine the built-in functions range and len. So remember, len numbers is going to give us the number of elements in our numbers list. We're basically saying for each element in the, by using range, for each element in the number of elements in numbers, okay, then numbers is equal to numbers times 2. So we're going to take basically each number of that element, in this case there's 2, and we're going to multiply it by 2. This loop traverses the list and updates each element. Len returns the number of elements in the list. Range returns a list of indices from 0 to n minus 1, where n is the length of the list. And it's n minus 1 because, remember our indices, if there's 10 elements in a list, there'll only be 9 indices. Each time through the loop, I gets the index of the next element. Because remember, it's a loop. The assignment statement in the body uses I to read the old value of the element and to assign the new value. So that's this here. Assignment is the equal. A for loop over an empty list never runs the body. Although a list can contain another list, the nested list still counts as a single element. The length of this list is 4. So here we have a list, and although it's got 3 elements, because it's a list that's nested in the list, it's only going to be 1 element. So this is 1 element, this is 2 elements, the 3rd element, and the 4th element. The plus operator concatenates lists. So this is what we did in our little exercise. It's still here? Yeah, over here. We concatenated the 2 lists into C. The star or the times operator repeats a list a given number of times. I didn't know that. So for example, 1, 2, 3, if we times it by 3, it's going to say 1, 2, 3, 1, 2, 3, 1, 2, 3. The first example repeats 0 4 times. Yeah, I suppose it's still a list, because even though it's 0, it's got 1 element. The second example repeats the list 1, 2, 3 3 times. Okay, before we get to slicing, I do feel that we are, let me just go back to the top of Unit 4. So 4.1, creating lists, we've done. 4.2, indexing, and then slicing. We need to understand indexing very well before we get to slicing. My concern is that while we are in a position to read and understand what the code is saying, we haven't really been applying it. I just want to see here. Next. We've covered this. Did you guys see while I was busy recording, old Brucey was chewing up his pillow? Hey, Bruce? Oh, he did the same with his bed this morning. You don't want to come to bed. See, there's evidence. Look here, look at that fluff. List slices. I just want to see how far we go. List methods. Map, filter, and reduce. It's still at 4.1. Well, I can see why this one takes 6 hours. Debugging. Glossary. It's nice that they're starting to introduce exercises. And I see there's a video here. Good. Sorry about that, guys. Let's carry on because I was worried. I was going to look for some practical exercises, but I see since they do have towards the end, we'll just, we'll do those. List slices. The slice operator also works on lists. So we've got a list here called T. Now, if we slice 1, 2, 3, remember 1 starts at B, and you'll know this if you watched our earlier videos on the basics of Python on learnpython.org. The 3 is exclusive, so we're actually going to stop at 2. So 0, then it's 1, 2. So it's only going to print B and C. Okay, we don't include the third index. In this case, it looks like we're stopping at 4. So 0, 1, 2, 3. Remember, we don't include E because we don't include 4, which is where we stop. And in this case, we're starting from index 3 onwards, and remember it includes index 3. So 0, 1, 2, 3. So it's going to print D, E, F. If you omit the first index, also notice, that the indexing or the slicing, uses also square brackets. If you omit the first index, the slice starts at the beginning. If you omit the second, the slice goes to the end. If you omit both, the slice is basically a copy of the whole list. So like here, we've omitted the beginning and the end, so it's going to just do the whole list. Since lists are mutable, it is often useful to make a copy before performing operations that modify lists. A slice operator on the left side of an assignment can update multiple elements. Okie dokie. So we've learned about, or we've looked at doing one element, changing one, but in this case we can actually change multiple elements. So in this case we're going to change B to X. Notice that here. And then 0, 1, 2, 3, C is going to change to Y. So this might feel a little bit confusing, but remember the stop here, or the end, is exclusive of index 3. So this actually means we're changing element number 2, which is 0, 1, 2. See here, it's become Y. List methods. Python provides methods that operate on lists. For example, append adds a new element to the end of a list. So remember with our methods, we say dot append, or we use dot. Extend takes a list as an argument and appends all of the elements. So we take list T1, we extend it by list T2. That makes sense. So originally our list was ABC, now it became ABCDE. This example leaves T2 unmodified. Very important to remember that. Sort arranges the elements of the list from low to high. So if we say T.sort, it will do it in alphabetical order, which is great. Most list methods are void. They modify the list and return none. If you accidentally write T equals T.sort, you will be disappointed with the result. What do they mean by this? Let's check with ChatGPT. I think it means you can't assign a variable. Am I correct that this statement basically means you can't assign a variable to a list method? Oh boy, ChatGPT is going to give me a hard time. Let me copy this and just refresh. Enter. In the meantime, Let's go to the next page. Still nothing. Why? Very annoying. My stream health is otherwise fine. Hey, Prissy. You're such a cutie. Please work. Sorry. Okay, map, filter, and reduce. We'll come back to that. To add up all the numbers in a list, you can use a loop like this. So we would say, this is the name of our function, add all. T is, if I recall correctly, the name of our list. Total equals 0. For x in T, total plus equals T. Return total plus equals x. Total is initialized to 0. Each time through the loop, x gets one element from the list, right, for x and t. The plus equals operator provides a short way to update a variable. This augmented assignment statement, plus equals x, is equal to total equals total plus x. Total, remember, starts at 0. As the loop runs, total accumulates the sum of the elements. A variable used this way is sometimes called an accumulator. Adding up the elements of a list is such a common operation in Python that Python provides it as a built-in function sum. So sum t. That seems easier. An operation like this that combines a sequence of elements into a single value is sometimes called reduce. Sometimes you want to traverse one list while building another. For example, the following function takes a list of strings and returns a new list that contains capitalized strings. So capitalize all T. So T is our list. We have an empty list. And we basically say for S in T, we will take our list here, which is currently empty, and using dot append, we'll basically take S and capitalize it. That's what the dot capitalizes for. And then it will return our res list. And remember, it will keep doing this because it's a for loop. It will keep doing this for all the elements in the list T. No, that's not working. Slightly annoying. Doesn't want to work. Let's try Aria. So I'll read the answer to you because I don't think you can see Aria. I'm using Opera GX. So remember when it said that most list methods are void, they modify the list and return none. So if you accidentally write t equals t dot sort, you will be disappointed with the result. My question was, am I correct that this statement basically means you can't assign a variable to a list method? Yes, you are correct. The statement you provided is accurate. When you use list methods in Python, like dot append and all of those, sort, many of them modify the list in place and return none rather than creating a new list. When you mistakenly write something like t equals t dot sort, you are effectively assigning none to the variable t. This is because the sort method sorts the list in place and returns none, not the sorted list. So, if you try to assign the result of t dot sort back to t, you will end up with none in t, which might not be the expected outcome. Therefore, it's important to be cautious when using list methods that modify the list in place to avoid unexpected results like assigning none to a variable unintentionally. That makes sense. That's something important to remember. So res, but going back to this example, is initialized with an empty list. Each time through the loop, we append the next element. So res is another kind of accumulator. An operation like capitalize all is sometimes called a map because it maps a function. In this case, the method capitalize onto each of the elements in a sequence. Another common operation is to select some of the elements from a list and return a sublist. For example, the following functions takes a list of strings and returns a list that only contains the uppercase strings. So we have only upper as our function for t. Again, we've created an empty list called res. And we're saying for s and t, meaning we want the for loop to loop over all the elements in t. But remember, this is now a conditional. So we only want the capital letters. So within the for loop, we're going to have an if statement. So if s dot is upper, only then will we append s to res, and then it will print the res string. Is upper is the string method that returns true if the string contains only uppercase letters. An operation like only upper is called a filter because it selects some of the elements and filters out the others. Most common list operations can be expressed as a combination of map, filter, and reduce. It sounded intimidating at first, right? Mapping. Okay, it's not that bad. There are several ways to delete elements from a list. If you know the index of the element you want, you can use pop. So in this case, we are saying t.pop1. So t becomes AC. I thought we couldn't do that. This is a list method. So isn't it supposed to return none? Let's check. So let's code for it. Yes. Isn't dot pop a list method? And we are assigning a new variable or X. Yes, you are correct. Aria is not as good as ChatGPT. It doesn't really explain why it's allowed with .pop. So the moment my ChatGPT is up, I'm going to just make a note here. Otherwise, if you are learning along with me, you can maybe do a check on that yourself. Pop modifies the list and returns the element that was removed. If you don't provide an index, it deletes and returns the last element. If you don't need the removed value, you can use the del operator. You know what I find a little bit overwhelming is like if you look at delete, there's no dot delete. So, to have to remember all these things. And as we're advancing, and Saylor's website goes through it so nicely, right? All the fine details. I think we're going to have to do like a sort of mind map to sort of get a visual of how everything fits together, but also how everything works. All of these functions and methods and, operators. We probably did cover this when we did operators, which I think was Unit 2. If you know the element you want to remove, but not the index, you can use remove. Yes, I remember that. Like in the previous example, it was 6, so it wasn't tied to the index, so it was a little bit confusing. The return value from remove is none. Yeah. So again, we won't be able to assign a variable to t.remove b. To remove more than one element, you can use del with the slice index. That makes sense. So we're going to delete everything from B up until 4. So this is 0, this is 1, 2, 3, 4. So it's going to print A and F. As usual, the slice selects all the elements up to but not including the second index. Lists and strings. A string is a sequence of characters, and a list is a sequence of values. But a list of characters is not the same thing. To convert from a string to a list of characters, you can use list. So we say list is. Because list is the name of a built-in function, you should avoid using it as a variable name. I also avoid it because it looks too much like 1. So that's why I use T. Oh, I avoid I, using I. The list function breaks a string into individual letters. If you want to break a string into words, you can use the split method. So remember, we use split. An optional argument called a delimiter specifies which characters to use as word boundaries. The following example uses a hyphen as a delimiter. Oh, so I suppose a delimiter could be a space, but it looks like split does that for you automatically. Maybe if you think of like your CSV file formats, right? when you want to basically open it up into columns, then you separate it you specify whether you want to separate it according to the dots or the commas. So I guess a delimiter is the same thing. Join is the inverse of split. It takes a list of strings and concatenates the elements. Join is a string method, so you have to invoke it on the delimiter and pass the list as a parameter. Makes sense? So here we just have a list of words, and then by using join, so here we just use delimiter, and notice we say split, dot split, and then delimiter, which is this here. Interesting. Now we say dot join. So now it will join. In this case, the delimiter is a space character. So join puts a space between words. So we made this a space. Interesting. To concatenate strings without spaces, you can use the empty string as a delimiter. Okay. Objects and values. If we run these assignment statements, so we have A equals banana, B equals banana. We know that both A and B refer to a string, but we don't know whether they refer to the same string. There are two possible states. Okay. In one case, A and B refer to two different objects that have the same value. Yeah, that's how I see it. In the second case, they refer to the same object. To check whether two variables refer to the same object, you can use the is operator. A is B, true. In this example, Python only created one string object and both A and B refer to it. But when you create two lists, you get two objects. So the state diagram looks like figure 10.3. In this case, we would say that the two lists are equivalent because they have the same elements, but not identical because they are not the same object. If two objects are identical, they are also equivalent, but if they are equivalent, they are not necessarily identical. Until now, we have been using object and value interchangeably, but it is more precise to say that an object has a value. If you evaluate, let's say, the list 1, 2, 3, you get a list object whose value is a sequence of integers. If another list has the same elements, we say it has the same value, but it is not the same object. Aliasing. If A refers to an object and you assign B equals A, then both variables refer to the same object. So A equals 1, 2, 3. If we say B equals A, then B is A, because A is 1, 2, 3. So they both refer to the same object. The association of a variable with an object is called a reference. In this example, there are two references to the same object. An object with more than one reference has more than one name. So we say that the object is aliased. If that alias object is mutable, changes made with one alias affect the other. Although this behavior can be useful, it is error-prone. In general, it is safer to avoid aliasing when you are working with mutable objects. So avoid it if you are using lists, in other words, as lists are mutable. For immutable objects like strings, aliasing is not as much of a problem. A equals banana, B equals banana. it almost never makes a difference whether A and B refer to the same string or not. Probably. List arguments. When you pass a list to a function, the function gets a reference to the list. If the function modifies the list, the caller sees the change. For example, delete head removes the first element from a list. So this is our function, delete head, T is our list, and we're going to remove the first element. That's why it has 0. Here's how it's used. Letters equals ABC, delete head letters. Yeah, because it deleted C. No, it deleted A, sorry. The parameter T and the variable letters are aliases for the same object. Yeah, letters, yeah. Since the list is shared by 2 frames, I drew it between them. It is important to distinguish between operations that modify lists and operations that create new lists. For example, the append method modifies a list, but the plus operator creates a new list. Here's an example using append. So if we append 3, it adds to the end of the list. And notice how T2 returns none. But if we use plus, so we say plus 4, then basically T3 doesn't return none. The result of the operator is a new list, and the original list is unchanged. This difference is important when you write functions that are supposed to modify lists. For example, this function does not delete the head of a list. So we want to delete the head. No. The slice operator creates a new list, and the assignment T and the assignment makes T refer to it, but that doesn't affect the caller. Hectic. At the beginning of bad delete head, T and T4 refer to the same list. At the end, T refers to a new list, but T4 still refers to the original unmodified list. An alternative is to write a function that creates and returns a new list. For example, tail returns all but the first element of a list. Okay. This function leaves the original list unmodified. So we have letters. Then if we print rest, it will, take out the first element. Careless use of lists and other mutable objects can lead to long hours of debugging. Here are some common pitfalls and ways to avoid them. Most list methods modify the arguments and return none. This is the opposite of the string methods, which return a new string and leave the original alone. So we need to know which list methods, because from what I can tell, it's not all of them that return none. If you are used to writing string code like this, it is tempting to write list code like this. Because sort returns none, the next operation you perform with T is likely to fail. Before using list methods and operators, you should read the documentation carefully and then test them in interactive mode. That's a good tip. 2. Pick an idiom and stick with it. Part of the problem with lists is that there are too many ways to do things. I agree. For example, remove an element from a list. You can use pop, remove, delete, or even slice. To add an element, you can use append or the plus. Assuming that T is a list and X is a list element, these are correct. Yep. And these are wrong. Try out each of these examples in interactive mode to make sure you understand what they do. Notice that only the last one causes a runtime error. Ooh, the other 3 are legal, but they do the wrong thing. 3. Make copies to avoid aliasing. If you want to use a method like sort that modifies the argument, but you need to keep the original list as well, make a copy. So remember, we did that with slicing. In this example, you could also use the built-in function sorted, which returns a new sorted list and leaves the original alone. Good to know. So we have our glossary. So list is a sequence of values. Elements. An element is one of the values in a list or other sequence, also called items. A nested list. A nested list is a list that is an element of another list. Accumulator. An accumulator is a variable used in a loop to add up or accumulate a result, like plus equals 1, times equals 2. It will keep timesing each element by 2. Augmented assignment. Oh, okay, don't take my example. I was referring to an augmented assignment, a statement that updates the value of a variable using an operator like plus equals. Accumulator. Is that probably just like a plus? A variable used in a loop to add up or accumulate a result. Okay, reduce. Reduce is a processing pattern that traverses a sequence and accumulates the elements into a single result. Map is a processing pattern that traverses a sequence and performs an operation on each element. A filter is a processing pattern that traverses a list and selects the elements that satisfy some criterion. Object, something a variable can refer to. An object has a type and a value. Equivalent, having the same value. Identical, being the same object. Reference, the association between a variable and its value. Aliasing, a circumstance where 2 or more variables refer to the same object. Remember, we need to avoid that when we are working with mutable objects like strings. Okay, and then delimiter, a character or string used to indicate where a string should be split. So we need to know these definitions. Probably a good idea to write them down, memorize them, not only to understand, but also, I suppose, to get used to the lingo. Like when we get exercises and we get something like use a delimiter to do this, this, that, we start to, make sense of it all. So I didn't want to push this video too long today. We are already on an hour and 40 minutes, so Unit 4 is quite long. I will see you guys in the next video where we are going to look at the examples, and I'm now seriously getting to a point, not that I feel I've underestimated, however, I do feel we need to actually work on a sort of mind map. I might just do that on the side and then introduce it within the series just to help us make sense of everything and also be able to memorize it. I'll see you in the next video, and thanks for watching.